Good morning, my dear students. Today, we are going to discuss about Newton's laws of motion. I know Newton's laws of motion is most interested topic for many of the students, especially Newton's third law of motion. If I ask you a question, what is Newton's second law of motion exactly? 90% of the students will kept blank. They'll not answer. They'll answer like F is equal to ma is the Newton's second law of motion. But that's not the Newton's second law of motion. That's a final expression which we get from the Newton's second law of motion. But my question is, what is Newton's second law of motion? State that. That's it. If I ask Newton's first law of motion also, 90% of the students will not answer. I'm not saying 100%. Some of the students can answer, so I'm really appreciating them. So the point is, for most of the students, the Newton's laws of motion is interested topic only for that particular instant. That's it. They'll not try to dissect the topic in their minds so that it can be reproduced at any point of time whenever it is required. So maybe inside the exam hall or outside the exam hall. Now, Newton's laws of motion we will start. In every Newton's laws of motion, there is a concept of force is included, right? What is the topic here is? Today's concept is Newton's laws of motion. As I had already mentioned, there are three Newton's laws of motion. Newton's first law, Newton's second law, Newton's third law. Right? Newton's first law, second law, third law. In all those three laws, there is a concept of force. Concept of force is included. About this concept of force, we had already discussed in our previous class. What was our previous class? Force, a vector quantity, which is having both magnitude and direction. So there is a concept of what the effects can be done by a force. Like force can change the direction of a moving body, force can change the speed of a body, force can change the state of a body, force can change the shape and size of a body. So these all the things we have discussed related to the force, along with the concept called resultant force, balanced forces, unbalanced forces, differences and similarities. All those contents will help in understanding these Newton's laws of motion, right? And without any further delay, and we will be starting Newton's first law of motion now. What is that? Newton's first law of motion now. And let's start Newton's first law of motion. What it states? It states that every body continues to be in the state of rest or in the state of uniform motion unless it is acted upon by an unbalanced unbalanced force. Look at the interesting statement here. From now, you should not look both right side and left side and ask you a question called what is the statement of Newton's first law of motion? It's so simple. Look at here. Try to digest the statement into your mind. So there is a lot of information in the statement itself. Not even in the concept. In the statements itself, there's a lot of information is hidden. Let's take out point by point. Every body continues to be in the state of rest. Any body in the nature you take it. It want to be in the state of rest or in the state of uniform motion. I told you, first law of motion, second law of motion, third law of motion, in all the laws of motion, there is a concept of force is included here. And let us include the force concept in the state of rest or in the state of uniform motion. Imagine, so there is a body which is at rest. So this is the body I have which is in the state of rest. What is the net force acting on a body here when the body is at rest? It's 0 newtons. Yes or no? Net force means all the forces acting on this body are balanced. Then the net force or the resultant force acting on it will be 0. Correct. Now, in the state of uniform motion. So this is the same ground. There is a body is moving with constant speed. Constant speed means acceleration is 0, yes or no? Definitely it's S. But acceleration is 0. The body will be moving with constant speed under the action of balanced forces, and in this case also net force acting on a body will be 0. Okay. Now, every body continues to be in the state of rest or in the state of uniform motion unless it is acted upon by an external unbalanced force. What is that? External unbalanced force, right? So what is that concept called external force? Listen. This is, for example, and this is the car. Look at here. So I have my own design of the car. So imagine this is the car. So inside there are a steering is also there, right? So there is a person here and the person here and the person is here. For example, he is the person acting a force on this part of the car, and he is the person acting a force on this part of the car, and he is the person acting a force on this part of the car. You can see this is the force F and this is the force F and this is the force F. Will the car move? Will the car move in this case? Tell me. No. So because those are the forces called internal forces. What are the forces called? Internal forces. Internal forces cannot accelerate the body. They are writing the same thing here. Internal forces cannot accelerate the body, whereas external forces can accelerate the body. External forces can accelerate the body. Listen. Internal forces cannot accelerate the body. So when you are inside the car and pushing the car with your maximum effort, even 100 of people are inside the car and pushing it with their 100% efforts, so the car will never move because all the forces are internal forces, as you are the part of the system and acting a force on the system, so that the force called internal force. For example, the same three persons they came outside the car and applying a force, and this is the force called external force. So what is this force called? External force. And this external force definitely will move the car, because now these three people are not the part of the system, they came as out of the system. Here in the first case they are within the system, they are the part of the system, but in the second case they are not the part of the system, they are out of the system and applying an external force which will definitely accelerate the body. See here, acceleration is not zero here, some acceleration will be there to the car. So that is the concept called external force. Now look at here, every body continues to be in the state of rest or in the state of uniform motion unless it is acted upon by an external unbalanced force. So this is the body you take, for example. As long as the body is at rest, the net force acting on it will be zero, acceleration zero. As long as the body is moving with constant speed, net force is zero because acceleration is zero. So what the first law, Newton's first law states is, unless an external force acts on this body, it will never change its state. I hope you got it. I hope it's very clear to you. As long as the external force is acting, that external force is external unbalanced force that cannot be balanced, that need not to be balanced. Right? As long as the external force acting on this body, it will never change its state on its own. This is just kept at this point. Imagine on a table, if I keep this pen like this, will it move from one place to another place by its own? Impossible, right? Imagine there is a ball moving on the ground with a constant speed. As acceleration is zero, the net force is zero, and it will be moving in a constant speed. Forever, it wants to move in the state of uniform motion. As long as external force is not acting, it wants to move forever. It wants to move forever. It will not change its state on its own. There is an external force is needed to change the state of the body. There is an external force is needed to change the state of this body. On their own, they cannot change the state of the body. Maybe from state of rest to the state of motion to the state of rest. I hope it's very, very, very clear to you. This is about Newton's first law of motion. It's clearly telling us the requirement of external unbalanced force which is required to start a body or to stop a body. Let us take a simple example, one more example than this. So another example here. So this is what the ground I have considered here. Imagine there is a ball which is rolling on this ball, rolling on the ground, sorry. So the ball is in the state of motion as long as an external unbalanced force is acting on the ball. It wants to, see, as long as there is no external force acting on the ball, it wants to continue in the motion. So the ball wants to continue its motion forever it wants to continue it, because it cannot change its state on its own. But in reality, what happened? In reality, it comes to rest. Yes or no? Yes or no? In reality, the ball will come to rest after traveling to a particular distance. Why? Why? So that's the question. Why? Ball is in the state of motion initially. Finally, it is coming to the state of rest. What we discussed? On its own, it cannot change the state of motion to the state of rest. But how it is happening here? Newton's first law of motion tells us there must be an external force acting on this body. So that's the reason, for sure, there must be an external force acting on the body. That is the reason in moving, in shifting the state of motion to the state of rest. So what is that external force? Because it is proven here, external force is required to change the state of a body. So that external force here, which is called friction. What is it called? Friction. Friction is also a force. Friction. Frictional force acting on a body opposite to the direction of motion. Then what happens? Speed of the body slowly reduces, and finally body will come to the rest state. Okay, clear? It is a proof of Newton's first law of motion. External force is must to change the state of a body. Okay, clear? So this is about Newton's first law of motion. So Newton's first law of motion is also called as law of inertia. Look at here. So what is the Newton's first law of motion? Law of inertia. So what is meant by inertia? How many types of inertia we will be discussing right now. So my dear students, what we have discussed, Newton's first law of motion is also called as law of inertia, and let's see about it. It's also called as law of inertia. So what exactly meant by the inertia? I'll write about it first, then we'll move into the concept of types of inertia. And you see here, inertia is the inability of a body to change from one state to the other. State of motion to the state of rest, or state of rest to the state of motion, right? So what is that? State of rest to the state of motion, right? So from here to here, or from here to here. So that's called inability of a body to change from one state to the another state. So that is the law of inertia here. An important thing, what we had already discussed. It is not a new topic. Already we had discussed this in Newton's first law of motion. Imagine this is the body which is kept on the table. On its own, it cannot change its state. So that's called inertia. This is the body will have some inertia. Imagine a ball which is moving on a floor where there is no friction. Right? Where there is no friction. On a smooth surface, as long as the body is moving, it wants to move further. Unless it is acted upon by an external force. Right? So, a body is in the state of motion. In that case also, it cannot change its state on its own from the state of motion to the state of rest. So that's the inertia of that particular body. Each and every body in the nature will have its own inertia, and that inertia will be depending on the mass of the body. I mean, if the mass of the body is more, the inertia present in that body also will be more. If the mass of the body is less, inertia present in that body will be less. But for sure, there is an inertia is available with any body in the nature with its mass. So that's the reason I'm writing here, a mass is the measure of inertia. What is that? A mass is the measure of inertia. Mass is the measure of inertia. So when mass is more, More is the mass, more is the inertia. Less is the mass and less is the inertia. Okay, so more mass, more inertia, less mass, less inertia. And I will give you two basic examples, right? Two basic examples. I have two cars I have. One car is a toy car, the another car is an actual car. To start the which body, you need less amount of force. 100% it's a toy car. Yes or no? To start the toy car, we need very less force comparatively. So what you can say? Inertia of the toy car is less. Inertia having by the actual car is more because of the difference is what? Because of the difference in their masses. So mass of the toy car is less, its inertia also will be less, right? I'm writing here. Inertia having by the toy car is always lesser than the inertia having by the actual car or the real car. Okay, and another example I will give you. During the class, imagine there are two boys sitting in the last bench. One boy is a very lean, the other boy is very stout. If I ask them to stand up immediately, which boy will stand up immediately? Tell me first. 100% the lean fellow, he will stand up first, right? And the fat boy, the chubby boy, will be standing slowly like this. Yes or no? Because of what? Because of inertia only here. So mass is more in the case of stout boy. Slowly he will respond because inability of that particular body to change from one state to another state. Till the time he is just sitting, he is in the state of sitting there. So there is an inability. The body will tell that, so I don't want to change the state of sitting mode to the standing mode. So that's called inertia. So whereas the lean fellow is having less mass, the inertia provided with that particular body is also less. Inability of a body to change from one state to another state is less in the case of lean boy. Understand? So that's a concept called mass is a measure of inertia. Right? And look at here, inertia and its types. Okay, and number one, inertia at rest, and number two, inertia at the body's motion, and number three, inertia at the direction of a body. Inertia at the direction of a body. Ready? Now, inertia means what? Inability of a body to change from one state to the other. That's it. Now, inertia at rest means what? Inability of a body to change from the state of rest. That's it. It's so simple. Inertia of the body to change from the state of rest is called inertia at rest. Inertia of a body to change from the state of motion is called inertia of motion. Inertia of a body to change from one state to the another state in its direction is called inertia at direction. Okay, clear? Now, well, let's talk about this with one simple example. Imagine we are moving in a bus, right? Imagine and assume that we are moving in a bus. Initially, the bus is at rest. We went inside and sat in the bus. The bus is not moving. It's almost half an hour. Still, we are in the position of rest, right? Listen to me carefully. Assume that we are still in the bus in the state of rest. Suddenly, the driver entered inside the bus and started the bus. When the bus started suddenly, in which direction we will be moving? When the bus started suddenly, we will be moving backwards. Yes or no? You can imagine, you might have experienced, not only in the bus, it may be in the car even. So when the bus starts suddenly, we will be falling backwards. Alright? So I'm writing here, we will be falling backwards when the bus starts suddenly. Why? Why? That's a question. Till the time we are in the state of rest. When the bus started suddenly, bus comes into the state of motion now. Understand? From the state of rest to the state of motion, the bus is shifting. But our body will resist the shift. The body doesn't want to change the state of rest to the state of motion. Understand? The body doesn't want to change from the state of rest to the state of motion because of the resistance offered by the body for this change. We'll be moving backwards, whereas our legs are in direct contact with the bus. Yes or no? The bus will be in motion. Our legs also will suddenly come into the motion and we move backwards. Clear? Sure. So that is the concept called inertia at rest. Inertia at motion is exactly opposite to this. The bus is already in motion. The bus is already in motion. So we are also moving in the bus. We are in the state of motion now. Okay. Suddenly the bus got stopped. Then in which direction we fall? Imagine, assume you might have experienced it. Try to recollect it. So bus is in motion. So the bus had got stopped suddenly. Then in which direction we'll fall? We'll fall backwards. Yes or no? Yes or no? We fall forwards in this way, right? When the bus stops suddenly, we fall forwards in this way. So that is inertia at a motion. Because our body doesn't want to change the shift. Our body doesn't want to move from the state of motion to the state of rest. So that's the reason. What happens? So this body will resist the change. But the legs are in direct contact with the bus, whereas the bus came to the rest, right? The legs will come to the rest and the rest of the body will move forward. So that's a concept called inertia at the motion. And the last one, inertia of direction. Imagine we are still in a bus. The bus is taking a sharp turn, right? The bus is taking a sharp turn in this way, right? You might have experienced the situation. We will be falling in this direction. We will be pushed in this direction. Yes or no? We will be pushed in this direction when the bus is taking a sharp turn. Why? Because of the direction change. We are in a sitting position when the bus is moving in a straight line direction. When the direction of the bus is changed, so definitely this body will resist for the shift from one direction to the another direction. So that's the reason, because of inertia of direction, we will be pushed in this direction away from the circular path. If the bus is taking a shift like this and we will be moving in this, we'll be pushed in this direction, right? So away from the circular path direction, we will be pushed because of inertia of direction. So there are so many examples of inertia of the rest, motion and direction. In your lower classes you might have studied them. But as it is the basics understanding of inertia and Newton's laws of motion, whatever we require for the first PUC topics, and we are just discussing them, the basics about it, right? This is the complete concept called Newton's first law of motion, right? I hope you understood the concept called Newton's first law of motion very well. Now we will be starting Newton's second law of motion. Newton's second law of motion, right? So let's start. Newton's second law of motion, right? So first let's learn about its statement, what it states that, right? So do not get worried by looking at the statement, right? Each and every point we will be discussing now. It states that the rate of change of linear momentum is directly proportional to an applied external unbalanced force, and it is in the direction of the resultant force, and it is in the direction of what? Resultant force. Okay, so let's read one more time Newton's second law of motion and its statement. The rate of change of linear momentum. Here, the linear momentum is a physical quantity. Okay, so like so many physical quantities in our nature, like force, acceleration, distance, displacement, speed, velocity, weight, like so many other physical quantities, linear momentum is also one of the physical quantities in physics. The rate of change of linear momentum is directly proportional to an applied external unbalanced force. You know about directly proportional relationship, and you know about applied external unbalanced force. You know about unbalanced force and also about the external unbalanced force, which will accelerate the body. Next. And it is in the direction of the resultant force. And what is meant by it is in the direction of resultant force? What is that it refers here? The term it refers the rate of change of linear momentum. And you know, the rate of change concept will be discussed later. In later sessions, we will be discussing about the exact meaning and the expression for rate of change. Okay, so don't worry about it now. So read it once again. The rate of change of linear momentum is directly proportional to an applied external unbalanced force, and it is in the direction of the resultant force. The only unknown quantity about the statement is a linear momentum. What is that? A linear momentum. So a linear momentum we need to understand first, to understand Newton's second law of motion, right? I hope it's very clear to you. Now let's start the topic called a linear momentum. Why the linear momentum? As the body is moving in a straight line, right? So we are talking about Newton's laws of motion as the body, by assuming that the body is moving in a straight line. So that's the reason a linear momentum is mentioned here. If the body is moving in a circular path, the same momentum will be there for the body, but it is called angular momentum. So that will be discussed in the first PUC topics. Okay, so linear momentum is denoted with the symbol P, right? Linear momentum is denoted with the symbol P. Now, what is that linear momentum? So this is the linear momentum is the quantity of motion. The quantity of motion contained in a body, it's called a linear momentum, right? So linear momentum is what? The quantity of motion contained in a body. Any body is moving will have some quantity of motion with it. The quantity of motion can be transferable, remember. So this quantity of motion can be transferable from one body to another body. The quantity of motion will be transferred. So I will give you the examples also. Alright, are you ready? Now let's see the example here. I have two cases. So the first case, for some time you need to imagine this is a gun, right? So don't think that it's a small pipe. Okay, so you need to imagine that it's a gun. So there is a bullet will be coming out of this gun. So imagine this is the bullet, and you know the mass of the bullet. How much will be the mass of the bullet? So let's say, can I say the mass of the bullet is some 100 grams? 100 grams, it's very, very less. And this bullet is moving with speed, I can say with 200 meters per second. So this is the bullet is moving. So this is the bullet is moving, means it will have some mass and it will also have with some velocity. Yes or no? Yes. Now, according to the linear momentum concept, this is the bullet is in motion, so that indicates this will have some quantity of motion. Right? It will have some quantity of motion. Now, can you stop the bullet with your hands? Just with your hands, can you stop the bullet motion? No. Impossible. Because of what? So, huge quantity of motion is contained in this body. We cannot stop it. Understand? Clear? Right. So, second case I'll tell you. So, you'll understand the concept of linear momentum far better than this. And I have a car. You know my own design of the car. Right? Now, the mass of the car is 2500 kilograms. It's a huge, big car of mass 2500 kilograms. And it is moving with a small speed comparatively. It's 200 meters per second, right? The bullet. It is a very, very, very small speed. It is moving, I can say, only 50 meters per second. 50 meters per second. Understand? Not even 100 meters, 50 meters per second. But it is having some speed, but the speed is less. Okay. Now the question is, as this is the body is in motion, it will have some quantity of motion contained in a body. So that's called a linear momentum. Okay. Now, can you stop this car? Can you stop this moving car? Tell me. Yes or no? No, right? Because of what? Because of its huge mass, in this case, you cannot stop the car. It's not you cannot stop the car. It is, exactly speaking, you cannot control the quantity of motion contained in this body with your hands. The same thing, you cannot stop the quantity of motion contained by the bullet. The one and only person can stop this bullet motion is Rajnikant. Yes or no? In one of his movies, so when bullet is moving in this direction, he'll be walking against the bullet, right? Okay. Keep it aside. That's an exception, right? So now we cannot, generally speaking, we cannot stop this quantity of motion because of its huge speed. We cannot stop the quantity of motion. We cannot control the quantity of motion in this case because of huge mass. Here, mass is more. Here, velocity is more. Okay, clear? So, when we are talking about the quantity of motion contained in a body, both mass and velocity plays an important role. It's not like only one quantity will play an important role. Both will play an important role. So, that's the reason. The linear momentum is written as the product of mass and velocity of the moving body. Mass and velocity of the moving body. Okay. So this is the linear momentum is a vector quantity. What is that? The linear momentum is a vector quantity. Okay. It will have magnitude as well as direction because linear momentum is mass into velocity, right? Okay. Now, and you can clearly see that initial linear momentum can be written with the symbol P suffix I. So which is mass into initial velocity, V suffix I. So final linear momentum can be written with a symbol P suffix F. F stands for final, and it's mass into final velocity. Mass into final velocity. So there is a change in linear momentum, right? So I am writing here change in linear momentum, which can be written as delta P. Delta stands for change. P stands for linear momentum. Change in linear momentum. What is the change in linear momentum? So final linear momentum minus initial linear momentum, which is equal to m into final velocity minus m into initial velocity. Here change in linear momentum is denoted with the symbol delta P, which is equal to m if you take it common, and the final velocity minus initial velocity. So remember, so this is the expression for change in linear momentum. As the SI unit of P is, what is the SI unit of linear momentum? Mass into velocity. Linear momentum is what? Mass into velocity. Mass is denoted with the symbol kilogram and velocity meters per second. You see here, kg meter per second is the SI unit of linear momentum. So when SI unit of linear momentum is kg meter per second, SI unit of change in linear momentum also will be kg meter per second. Okay, so SI, a unit of change in linear momentum, also can be kg meters per second. Is it clear? So this is how the concept of linear momentum can be discussed, and we also discussed about the change in linear momentum. Okay, clear? Now look at here. The rate of change of linear momentum will be discussed in the next class, along with the completion of second law of motion and numericals and third law of motion. Okay, so this is how Newton's first law and second law we will be discussing.